Hello students, welcome to tutorial number 10. Those doing physics 1010. So in this tutorial, I'll be recording a video for each question. Yeah, because I understand there are those of you who might have solved some of these. So instead of making you watch a video for 20 minutes, I would rather you just pick a video on the question you're interested in. Okay, so in this tutorial we shall be looking at the ideal gas law and thermal properties of materials. Okay, that actually involves a bit of calorimetry. All right, so let's look at question 1 here. Question 1, we have this ideal gas in a container of volume 5 liters, and this gas is at a pressure of P1 and a temperature T1. Okay, so this container of the gas is connected to another container, a 20 liters container this time, of the same gas at a different temperature and at another pressure P2. So when you read this question, you are going to discover that you have two containers. Okay, each container containing a particular volume of the gas at a given pressure and temperature. So when we neglect the connecting pipe, it's more like we are mixing. So it's like we are dealing with two gases, okay? Though it is the same gas, but I would like to consider this system as one of two different gases, and then you simply mix them, okay? So there's one thing that you need to take note of. If we say we mix these two gases, they are going to form a new volume, which is the addition of the first container and the second container. So meaning the third or the new volume at equilibrium is going to be the sum of the two volumes. Also note that the number of moles here is also going to add up. Okay, so the number of moles for gas 1 in the smaller container plus the number of moles of gas 2 in the bigger container will sum up to N3, which is the number of moles for the combined gases. Okay, so we are achieving equilibrium as we mix these gases, and therefore we are going to have a new temperature, a new volume, and also a new number of moles. Okay, so if we consider volume 1 to be V1 and volume 2 to be V2, and the sum of these giving us the V3, which is the volume after combining the two gases and after they have achieved equilibrium. Okay, we do the same for the number of moles. We have N1 plus N2 giving us N3, which is the number of moles after the gases have reached equilibrium. Okay, so let's take a look at this. We have that V1 plus V2 is going to give us V3, and also that N1 plus N2 is going to give us N3. Okay, then for the data in the question that we are able to get, we are given that volume 1 is 5 liters, so we convert that to cubic meters, and we're going to have 5 times 10 to the power minus 3 cubic meters. We do the same for V2, we convert to cubic meters, and we're going to get 2 times 10 to the power minus 2 cubic meters. Okay, so the pressure for the first gas is given as 2.5 times 10 to the power 5 pascals, and the pressure for the second gas is unknown. Okay, so in this case we want to find the pressure for the second gas. Okay, so the temperature initially for the first gas in the small container is given as 293, converted from degrees Celsius to Kelvin. The same also for temperature for gas 2, we convert to Kelvin. When they attain equilibrium, the temperature is T3, so we convert that as well. We are going to have 296. And also the combined volume, which is V1 plus V2, we add that and then we convert to cubic meters. We get 2.5 times 10 to the minus 2 cubic meters. Okay, now we know that we are looking for P2. Okay, we are looking for the pressure of the gas in the second container. But we know the ideal gas law gives us that PV. Okay, so there's let me just rewrite this right here. Okay, so it's giving PV equals nRT. All right, so this one we know. Now since we are looking for pressure P2, okay, we're going to have P2, okay, equals N2 R T2, and this is actually supposed to be divided by volume 2 as well. Okay, so we have N2 R T2 over V2. So this is how we find the pressure in the second container. But notice that in this formula for P2, we have two unknowns. We don't know what N2 is, okay? So we cannot find P2 unless we know what N2 is. Now remember, in the first place we said that N1 plus N2 is going to give us N3, implying that to find N2 we simply subtract N1 from N3, meaning N2 equals N3 minus N1. Okay, so we can consider this as our equation 1. So N3 and N1 can be obtained easily. Okay, we simply manipulate the same ideal gas law for each of these. So if you want to find N3, therefore we will say N3 equals if we want to find N3, we consider the pressure of the gases at equilibrium, which is P3 equals N3 R times T3, from which we're able to obtain N3 as N3 equals P3V3 over R T3. Okay, so we have P3, we have V3, we know R, and we also have T3. Therefore, we can simply substitute these values into the formula, and from that we're able to find the value of N3 as 1.52 moles. All right, so now we have found the value of N3. Now we still go back to equation 1 there. We know that N2 is going to be given as N3 minus N1. Since we know the number of moles for gas 1, or rather N1, we are going to simply substitute into this formula, and having found the value of N3 as well, that makes things even easier. Okay, so we have that N2 equals 1.524 minus 0.513, giving us the value of N2 as 1.01 moles. Okay, so now that we know the value of N2, we can go back and find the pressure of the gas in the second container, the value of P2. Okay, therefore we have P2 equals N2 R T2 over V2. Okay, simply substituting those values after finding the N2, we have the values, multiplying there, and we divide by the volume in the second container, giving us the value of P2 as 1.25 times 10 to the power 5 pascals. All right, so the key here was simply on finding the value of N2, or rather the number of moles of the gas in the second container, and after doing that you'll be able to find the pressure in that second container. Okay.